All right, Algebra 1 students, welcome to your 7.5 notes. And I chose that song because the radical can't hold us. Basically, when you have stuff inside of the radical, you're going to learn today that you can basically put that stuff in the exponent as a fraction. So you can't hold that stuff inside of the radical. So here are your 7.5 notes. We have this thing called the index right here that we need to pay attention to. We have a radical symbol, and we have the stuff inside of the radicals called the radicand. Just a little bit of terminology for you that you need to know. And then we also need to understand the other big idea is that if you have a to the m over n power, this stuff right here basically means that you can change the form of that into radical form, and you can also go from radical form back into exponential form. So you can go back and forth between those two forms. And this right here is just another way to write the same thing. So there's different ways you can write the radical form, and we're going to show you some examples of that today. So here we go. Number 1, we've got the cubed root of 27. So we're trying to figure out if we raised some number to the third power, what would we get, or what would that be? What would that x value be to equal 27? And so if you wanted to, you could take your calculator and use the guess and check process, where you took 1 and multiplied that 3 times, you'd just get 1. If you took 2 and multiplied that 3 times, and you're not multiplying it by 3, you're taking 2 times 2 times 2, you'd get 8. If we did that with 3, we would have 3 times 3, which is 9, and then 9 times 3, which is 27. So hey, there's our answer. Number 1 simplified would simply be 3, because 3 raised to the third power would be 27. Okay, so that's how we simplify number 1. On number 2, that one's kind of funny because basically we're looking for something that we can multiply by itself 17 times to get 0. Well, folks, that one's just 0. All right, and then here we go with number 3. So we've got some number we can multiply together 5 times in order to get 32. And there's a different way that I can go about trying to find this number. I could start by dividing this by 2. So if I did that, I would have 2 times 16. All right, and if I multiply those together, I would get 32. And if I multiplied 16 together, I could get that by doing 4 times 4, and then I can break that down even further. 2 times 2 is equal to 4, and then 2 times 2 is equal to 4. And hey, check it out. I've got 5 different things sitting inside of that radicand that I could pull all of those out. So this simplified, number 3 simplified, would really be 2. And I would encourage you to go backwards on that and multiply 2 times itself 5 times on your calculator. See if you get 32, because you will. All right, so for number 4, I'm just going to follow the instructions. It just tells me to write that in radical form. So x raised to the 1/2 power means that, I don't want to move that around. I want to be writing. Means that I'm going to have a radical. This 2 right here is going to be what goes in my index. So 2 goes there. X to the first power goes there. And we really don't write, in algebra, we really don't write this 2 in the index. We really don't write the 1 in the exponent. So really, the answer for number 4 is simply the square root of x. All right. So we're going to do the same thing on number 5, but on number 5 we have to be tricky, or it can be tricky for some of us, because some of us like to think about this like we need to apply this exponent to both the 12 and the w, but you don't have to. In this case, there's not a parentheses sign around the entire thing. So really, we have 12 hanging out here in front, and then we're going to have a radical symbol with a 3 in our index and a w to the 4th power. All right, that 4/3 power is only applying to the w. Now, it would change if we had a parentheses around the entire 12w, but we do not. So number 6 kind of helps us with that, because really It's kind of the opposite of what we just did. We've got 16z with a parenthesis around the entire thing. And then we've got that entire thing raised to the 5/4 power. So I can rewrite this by simply writing a 4 in the index and then 16z. And I need to put this in parentheses because it is raised to the 5th power. And that's how you rewrite number 6. And I'm not going to simplify that. It doesn't tell me to simplify that, which means that I would actually take 16, raise it to the 5th power, and then find the 4th root of that. That would be simplifying it. All the instructions asked us to do was to write it in radical form. Basically just rewrite that. Okay, so it is a little simpler than sometimes we want to make it. And then in number 7 through 9, we're going to basically be going back the other direction. So number 7 would be a raised to the 7/4 power. All right. Number 8 would be 36 x raised to the, and actually I'm gonna slow down just a little bit because in order to raise that one to the power that I need to actually simplify that 36. The square root of 36 is 6 times 6. So I can circle 2 of these guys. Basically those 6's can come on out of that radical symbol, and then I would have 6 radical x to the 6th power. All right, and then I can rewrite that as 6 raised to the power, or 6x raised to the power of 6 over 2. And if I actually take that and divide that out, it's really 6x raised to the 3rd power. So that one really required a little bit more work because we didn't have a parenthesis. Let me use a laser pointer. I didn't have a parenthesis around this 36 here. Okay, so I actually had to break down that 36 and figure out what the square root of that was going to be. All right. All right, so number 9, let's take a look at that one. We have a parenthesis around this entire thing, so we really have 16w, and I can put a parenthesis around that as well. And then that is raised to the 3 over 6 power, and I could simplify that. That's 16w raised to the 1/2 power, because I could divide both the numerator and the denominator of that exponent by 2. Or I mean by 3, I apologize, and then I would get 1/2. Okay, so on to the next one. Okay, so folks, remember from our previous sections in Chapter 7 that if I'm multiplying powers of the same base, I'm really going to add them together. So what I really have here is x raised to the power of 2/3 plus the power of 1/4. So I need to figure out what the answer to that equation is. And if I want to do that, I need to change and have common denominators. All right, so really, I'm going to have 12 as my common denominator. And 12 divided by 3 is 4, and 4 times 2, well, that's 8. Okay, so that 8 twelfths is what 2/3 is really equal to. And 12 divided by 4 is 3, and 3 times 1 is 3. So I really have the fraction of 3/12 there. If I add both of those two things together, what I really have is x raised to the power of 11/12. Okay, and then in number 11, I've got x to the 2/3 power, and I've got 8x raised to the 1/3 power. So really, I need to apply that 1/3 power to both of the things inside of that set of parentheses. So I have 8 raised to the 1/3 power, and that is multiplied by x to the power of 2/3 plus the power of 1/3. Okay? And if we remember from our previous couple of slides here, this 8 raised to the 1/3 power, well, that's really equal to 2 because it is an 8 with a radical around it and a 3 in the index, which means I need to be able to multiply something 3 times. And if I was to break that 8 down, I could break it down into 2 times 4. And I can break down that 4 into 2 times 2, and then I can circle 3 2's to pull those guys out, and so that's how I came up with this 2 right here. Okay, so 8 to the 1/3 power, that's equal to 2, so I really have 2 times x, and we really don't write that in algebra, so I'll just say 2x raised to the power of 3 over 3, and that's actually equal to 1. And we really don't write a 1 in the exponent in algebra, so really the answer for number 11 is 2x. All right, so that's how you do number 11. All right, so number 12, 13, and 14 are instructions say to simplify and write in exponential form. So I'm going to start by doing the writing in exponential form portion. I meant to underline that, not move the entire screen on you. Sorry about that. So really I have 4 raised, and then I've got an a raised to the 7/5 power. I don't know what I'm doing here. I'm writing this wrong. 4 raised to the 7/5 power. Okay? And I'm subtracting 6a raised to the 7/5 power. And if I think about that, it's kind of like if I was going to subtract 4 minus 6, because those variables can kind of attach along. If I have 4 of this and I subtract 6 of the exact same thing, I'm going to have a negative 2a to the 7/5 power. All right? All right. Sorry that I had the video paused while I was writing that out. My 3-year-old actually brought me some Skittles in the middle of recording this, and so I wanted to eat them. So that's why my voice was gone while I wrote that. So there you go. Folks, if you think back over our section, we don't really have any notes on what to do when we have a subtraction sign for powers of the same base. That's because there is no rule for this. This, number 13, we are done right there. We are done. We don't have to do anything else to number 13. So let's move on to number 14. Okay, we've got x raised to the 6/3 power when we rewrite that in exponential form, and then we have 3 times x raised to the 4. And that's not a third power there. I need to pay attention to what I'm doing. That is a 4 over a 2, because when there is nothing written right there in that index, that really means that there's a 2 right there. And I don't like how I wrote that little 0 there. I was really kind of meaning to use my laser pointer when I was referring to that index right there, so don't confuse that. There should be a 2. In fact, let's write a little 2 right there instead. There's a little 2 right there in that index. So this is really x raised to the 2nd power minus 3x raised to the 2nd power, which is really negative 2x squared. Okay? So, folks, that concludes your notes on how to write things and simplify things in exponential form. And I hope you come to class ready to work.